Good DTKB day everyone! Today we're going to discuss our content creation about solving F.E.W equation.
In this video, we are expected to compare the relative wavelength of different forms of EM wave, solve problem involving wavelength, frequency, and energy of an EM wave.
Formula to use. First equation. Wave speed is equal to wavelength over frequency.
Wave speed is symbolized by a small letter v and is expressed meter per second.
Wavelength is symbolized by lambda and is expressed by meter.
Frequency is symbolized by a small letter f and is expressed in hertz or in symbols hertz, as written as capital H and small c.
Speed of light is symbolized by a small letter c and is expressed 3 times 10 raised to the power of 8 meter per second.
Energy is equal to Planck's constant over frequency,
wherein energy is symbolized by a capital letter E and expressed joule.
Planck's constant is symbolized by a small letter h and is expressed 6.63 times 10 raised to the power of negative 34 joules.
If wave speed is unavailable, replace its value by the speed of light.
Hertz is equal to 1 cycle, thus a complete cycle convert to 1 second.
energy is equal to Planck's constant, wave speed over wavelength.
Solve the following word problem while observing proper GRESA format, significant digit, and unit cancellations.
Question 1. What is the frequency of an EM wave that has an energy of 1.989 times 10 to the power of negative 10 joules? In what region of EM spectrum does this wave belong?
This problem, we need to use two solutions because frequency and wavelength are busy.
First, we need to identify the given. The given in this problem are energy, which is 1.989 times 10 raised to the power negative 10J, and Planck constant, which is 6.63 times 10 Js. The significant digit here is 4 and 3.
After identifying the given, what is required or what is unknown? So required here is the frequency.
So what will be the equation to be used in this problem? We may consider the second equation, which is energy is equal to Planck's constant over frequency.
Since we are looking for frequency, we need to use triangulation method. The equation will be frequency is equal to energy over Planck's constant.
Now, let's proceed with the solution.
Frequency is equal to 1.989 times 10 raised to the power of negative 10 joule divided by 6.63 times 10 joules.
First divide 1.989 and 6.63 is equal to 0.3, bring down 10 and combine negative 10 and negative 34. Cancel the same unit which is joule and the rest is second.
Then negative times negative is equal to positive, so negative 10 plus 34 is equal to 24.
0.3. Let's move the decimal point on the right. The result is 3.0 times 10 raised to 20 per second. And add minus 1 because we moved decimal point, so 24 minus 1 is equal to 23.
So our answer is 3 times 10 raised to the power of 23 Hertz.
Now we have found the frequency. Let's move to the next solution.
Same procedure as the first solution.
The given are frequency 3 times 10 to the power of 23 Hz. You need to convert Hz into seconds. Since we don't have wave speed, we will use speed of light, which is the numbers of 3 times 10 to the power of 8 meters per second.
So required here is the wavelength. So what will be the equation to be used in this problem? We may consider the first equation, which is wave speed is equal to wavelength over frequency, and we need to use the triangulation method again. The equation will be wavelength is equal to wave speed over frequency.
Solution: wavelength is equal to 3 times 10 raised to 8 meter per second divided by 3 times 10 raised to 23 second. Cancel the same unit.
3 divided by 3 is equal to 1 times 10 raised to 8 minus 23 meters. 8 minus 23 is equal to negative 15.
So our answer is 1 times 10 raised to the power negative 15 meters.
In what region of EM spectrum does this wave belong to?
Our answer can be seen in gamma rays.
Is express 6 points. Di ko na alam.
The equation will be
Bring down 10 and combined
Speed is c